This is a presentation about technology, cities and design, but also nature, evolution, self-organization and their bundled nature. This is not, therefore, an academic lecture as such, more of a thought experiment built on a chain of what-if scenarios. Today, perhaps the most common discourse in urban studies regards to planetary urbanization. At the same time, we are at the threshold of a digital technological revolution, implying the use of AI-guided or smart systems for taming the big data that keeps piling up. It appears that cities are becoming increasingly important in both causing and possibly providing solutions to resulting urban socio-economic and ecological challenges. However, I think our stance in this matter is mostly fairly conservative and conventional. We try to solve unusual situations with business as usual solutions. Participatory tools, at least those just extending the linear thinking towards more inclusive actions arising from same assumptions, provide little help. For this presentation, I explored several websites promoting possibilities of AI, smart systems and big data in design. I encountered with some promising language stating, for example, that architects should learn to understand how city will flow. Spaces are complex living, data-driven organisms communicating with themselves, and that smart city forces architects to rethink their traditional models. At the same time, the smart city design reproduces the same modernistic ideals apparently coming from engineering or business management department, linear efficiency and optimization of systems coated with glass and steel. In the light of these, instead of groundbreaking holistic approach, smart city reveals itself as traditional, linear, rational and control-oriented city model, just like those promoted by modernism. It seems to me that the city of today is a machine more than ever. Right now we hover between embryonic understanding of the surprising nature of urban dynamics and flows, sudden changes, autonomous characteristics and unpredictability of cities, and the control-oriented linearity we are familiar with. But we only have to take a look at the world under the pandemic to realize the intrinsic uncertainty of the complex systems we live in. In this sense, societies and cities are quite similar to other ecosystems in nature. Both consist of nested subsystems with myriads of interlinkages resulting in surprising dynamics on the higher level while co-evolving. They are rarely linear or easy to control and never static, and they don't aim at certain equilibrium. Often, if they find a permanent perfect end state, they are dead. Life is in reality messy, intertwined, consisting of networks of complex adaptive systems. However, there are mechanisms that produce enough order to keep the system on the edge of chaos, not falling over, and that is called self-organization. Self-organization is the most important mechanism in complex adaptive systems through which they form resilient organized structures that help them to survive. By definition, self-organization means that there is no external guidance, but the system organizes from the internal premises, implying dynamic interaction between the parts. This process takes place on many scales and in many types of systems, from molecules, cells to organisms and even cities. In natural systems, self-organization is quite common. It can be considered as a form of pre-evolution. It's not conscious, but the system benefits from these structures one way or another. Self-organization may reduce friction, save material, or maximize the surface for photosynthesis. In addition, self-organization changes the environment. The emerging pattern starts to enslave the system. The bushes in the desert improve the surrounding soil, making it easier for the seeds to sprout, producing resilient dynamic patterns. The heartbeat emerges through self-organization as well. As one cell contracts, its neighbors do that next, creating a dynamic pulse traveling through the tissue. Interactive impulses in individual level give rise to a resilient pattern typical for the organ's autonomous operation. In cities, many types of activity clusters and networks are self-organizing structures. The actors gravitate close to the competitors for their benefit. They make individual conscious decisions but without knowledge of the whole. Simultaneously, they form patterns on a higher scale that attract more actors and so on. Self-organization of neural impulses in brain have inspired many computational applications. Teuvo Kohonen introduced already in 1980s a groundbreaking paradigm for artificial neural networks called self-organizing maps. They imply computing functions just like those taking place in the brain emerging autonomously, building paradigm for unsupervised learning in computer science, even for a self-organizing hardware structure. Furthermore, also higher cognitive processes above cellular level, such as memory, follow similar self-organization. In the dynamic memory model, the cognitive processes, understanding, learning, and memorizing are intertwined. Individual events form self-organizing clusters, remindings. Remindings are recalled and adapted for problem solving in a new situation. This has offered an inspiration for case-based system in computing where prior solutions form a library that can be adjusted, combined, and adapted for solving new problems. The classical example, the game of life from early 1970s, brings this autonomous order formation to the simplest possible level. With an elementary computational and iterative cellular system based on local rules between cells, John Conway was able to give rise to various dynamic states for the system, but most importantly, prove that non-living entity is capable of reproduction, which was considered to be a profound feature of living organisms. These examples of applications of self-organizing principles may start to bridge the gap between natural and artificial in our minds, opening up possibilities for more general system ontologies. Overall, self-organization appears as common underlying principle in how nature dynamically, so to say, optimizes different systems to autonomously seek for most flexible, adaptive, and hence dynamically evolving solutions. And here we must see the difference between the static optimal solution, an end state, and this mechanism for semi-permanent evolving states. As said, self-organization resembles evolution. After trialing variety of solutions, the fittest, that means those best adapting to the environment and therefore benefiting the system, will survive. Many complex systems, if not all, follow somewhat similar principles of autonomous order formation. It's been suggested that self-organization is responsible for the emergence of life itself. Consequently, in this thought experiment, I would take this even further. There is nothing in the universe that is not nature, and all complex adaptive systems, even the human artifacts, despite that they are product of our conscious actions, are following more or less similar laws. Adopting deep ecological view instead of anthropocentric perspective, perhaps everything is nature, and there is nothing unnatural or supernatural in the world. We are part of the nature, not standing outside of it. Traditional cities built before the first industrial revolution and emergence of modern planning have emerged in evolutionary or computational manner. Each building is iteratively adapted to the existing ones and the environment, giving rise to gradually emerging local rules that start to steer the system. The new buildings will follow these rules that might regard relation to adjacent buildings, routes, slopes, or views. Such urban evolution can be considered to be a self-organizing process in many senses. Similar processes are currently prevalent in many informal settlements across the world. In such systems, the rules are essential. There are two types of rules, emergent rules and normative rules. They differ from each other in a similar manner than in linguistics. Emergent rules self-organize within the process of how language is spoken. In cities, these resemble regularities and relations emerging within the becoming of cities. Grammatic rules limit the legitimate use of language. These are a bit similar to urban plans, reflecting the reality while guiding it. In self-organizing cities, the emergent rules rise from human interaction, while normative rules aim at guiding the process. They should, however, reflect the preferable forms of self-organization. We can see certain resemblance with typomorphology in how we understand the cities and towns evolve. The formation of cities can be seen as a self-organizing process where local rules emerge. They appear in local variation of basic buildings and how they are adapted to routes, neighboring buildings, topography, climate, and other environmental factors during spontaneous consciousness. Now, if we return to the smart city discourse, where the corporeal and virtual urbanity are intertwined through AI, smart systems, data management platforms, and designing tools, we can now ask, are we facing a fast transition typical in complex systems, not completely different from industrial revolution, one during which we need critical consciousness for innovating novelties? With other words, is this the moment when we need unique, artistic, creative human mind? Traditionally, that would mean design innovations, but now we, designers, are starting to wonder to which extent AI can assist in design. I have always thought there is something deeply different and profound in human mind, that art is something special, mysterious, inimitable. Now, as I step back to think about the overarching theme of self-organization and wonders of nature that are artworks themselves, I am not anymore so determined. It might be that if we could build a digital neural network even partly as complex as systems in the corporeal world, it might, at some point in the future, be capable of producing something as complex, surprising, and fascinating as nature, to produce emergent rules, perhaps even innovate. However, could we humans appreciate it? Art is also cultural. We can see that so-called computer streams or emergence of their own language when two AIs discuss are quite eerie. So I'm wondering, should we adopt this transhumanism, extending our bodies and cities with technology and AI? And, if so, on which conditions? Actually, we have always co-evolved as species with technology and later with cities. Instead of rock, we now have cell phone in our hand, almost non-stop, and it connects us to other human machines and machines. We are networked cyborgs by definition. This also pushes us to rethink our coupled relationship with technology, machines, and cities. It can be co-evolutionary on a whole new level. For certain, the boring road of linearity, end-state optimization, and efficiency is a dead end, and as architects and visionaries, we should be already looking in different directions, for example, towards autonomous structures. Such systems would not just obey our simple normative rules, they have capacity to build their own self-organizing emergent rules and realities, communicate and respond to each other and their environment, and I believe they eventually will. As designers, we need to take a stand on that, either actively participate in and steer this process, or ignore it, and perhaps end up leaving it to the mercy of computer scientists, engineers, and business managers. How we will relate to this situation ethically as well as in social and culturally resilient way is not a simple question, and I'm not sure if there can be a straightforward answer.